Van Halen. No, no, no. Jimi Hendrix. Wow, 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 wow. Stevie Ray Vaughan. Well. And Jimmy Page. No. When you hear these names, what comes to mind? These men have all gone down in history as masters of their instrument, the guitar. According to the Almanac of American Recreational Preferences, about 7.5% of Americans play guitar. While the guitar we are most familiar with today has only been around for the past century, the physics that give the instrument its characteristics have been around since its ancestors were first created by early civilizations. Today, we will go over the history of the guitar, learn about the types of guitars, and learn about the scientific factors that make the guitar the instrument that it is. This guitar is an acoustic guitar. This means that the main part of the guitar is hollow and allows vibrations to resonate and be amplified by itself. The earliest guitars were acoustic, and its strings made of dried animal intestines. Although this type of string can still be purchased today, they aren't as popular anymore and must be specially made by hand. Today, strings are either made of nylon or steel. Steel strings are what you see on these guitars. In the early 20th century, nylon and steel strings were first introduced. They became widely popular among blues and rock guitarists for their durability and new sound. In the 1940s and 1950s, the first solid body electric guitars were produced. Solid body means that instead of being hollowed out to resonate from vibrations, guitars are now able to be amplified with pickups. Guitar companies like Fender, Teisco, Gibson, and Harmony released many different lines of solid body guitars. Fender and Gibson are the two biggest guitar producers today. According to Fender, their most popular model is the Stratocaster. Artists that use the Stratocaster stretch from Jimi Hendrix to Eddie Van Halen. Gibson's most popular model is the Les Paul, named after the famous guitarist. Artists that use the Les Paul stretch from Slash to Jimmy Page. There are many different parts on the guitar. This brown piece of wood here is called the bridge. This is the start of the scale length, which is where you can get sound from the guitar. Moving over, this is the sound hole, which is where the sound is projected from. Moving up, this long stretch of wood here is the neck, and at the end is the headstock. These metal pieces turn and add tension to the string, or tune it. They're appropriately named the tuning pegs. A majority of the guitar science revolves around strings and their tension. The guitar string is held tight at both ends. When you pluck a string, the string vibrates, producing sound waves. These sound waves are special though. Because the string is fixed at both ends, the waves are standing waves. A standing wave is defined as two waves with the same frequency, wavelength, and amplitude, traveling in opposite directions that interfere to create the standing wave. These standing waves rise and decay, and the speed at which they do this depends on the tension on the string. On a tight string, the waves move faster, making the note sound higher in pitch. The opposite is true for loose strings. On a loose string, the waves move slower, making the note sound lower in pitch. Another factor in the sound of the guitar is how you pluck the string or where you pluck the string, either over the sound hole or near the bridge. Sam Hogan, a physicist and teacher, conducted an experiment on this concept. These are his observations. When the guitar string was plucked over the sound hole, the initial pluck was the loudest point in the vibration. This method gives more of a mellow tone to the string. This method is used to get sounds for rock, pop, and many other genres as well. Plucking the string near the bridge, however, creates a much different tone. The tone is much richer, and unlike the other method, the note dies out quicker. Moving to the electric guitar now, many of the physics are the same. Plucking the two different areas gives you the same results, but what is truly special about the electric guitar are the pickups. The concept of the pickup is rather simple. Take the ones here, for example. These pole pieces are magnets, which have wires wrapped around them to form coils. When a string is plucked, it makes a change in the magnetic field, creating a signal, which is then sent to the amp. From there, it is projected out of the speaker for us to listen to. Another factor in the sound of the guitar is the shape of the body. On this guitar, the body is made of two types of wood, in this case, spruce and NATO, and is shaped somewhat like a box. But notice the flat back. One guitar company, Ovation, revolutionized the way acoustic guitars were made with the introduction of the round back guitar. These guitars look like normal guitars from the front, but the back is actually a bowl shape. The composite bowls from Ovation are carbon fiber bowls that have a rough shape of a guitar body. With improvements in the construction of these bowls, vibrations of the bowl can be taken advantage of. It has since been proven that these guitars do improve tonal clarity and allow notes to resonate within the guitar for longer. Sadly, because of their look, many guitarists would refuse to use one on stage. However, artists that use Ovation roundbacks include Glenn Campbell, Richie Sambora, John Lennon, Neil Diamond, and Eddie Van Halen. Also, if you look at these guitars, there's not just one sound hole, like on that guitar, there are many smaller sound holes. This is to project the sound more. Because the sound can resonate within the guitar for longer, the location of the sound hole being at the top of the body allows the sound to push further out of the holes. This further contributes to an overall better sound. Over the past century, guitars have changed. From the materials used to make them to the artists who play them, one thing has stayed the same: the science. And with all these things combined, we see how truly great the guitar is. Thank you.